Hello, and welcome to Geography 311, entitled Earth, the Habitable Planet, An Introduction to Earth System Science. My name is Dr. Jesse Wilson, and I am going to be your instructor for this course. This is the introductory lecture, in which we will cover how the Earth is a closed system and briefly describe its different spheres. We will also define some terms that we will cover a lot in this class, and go over some Earth system examples of how changes in one aspect can have far-reaching effects. So let's get started. First, we will define Earth system science. Earth system science is the study of Earth as an integrated whole. The Earth functions as a collection of interconnected parts that influence each other. We will better define what a system is and what Earth's spheres are in the coming slides, but the different spheres on Earth are shown in the image to the right. Earth system science is an interdisciplinary science that incorporates math, physics, chemistry, biology, geology, oceanography, atmospheric science, and more. There is an interdisciplinary science that is an important part of Earth system science, or Earth science, called biogeochemistry, which is the cycling of elements on Earth that involve life. The carbon cycle or the nitrogen cycle are examples of biogeochemical cycles. There are biotic and abiotic transformations of compounds that contain those elements, thus cycling them. Climate science is also a very closely related field. Finally, due to the size of the Earth, remote sensing, including satellite imagery and mathematical modeling, are major tools for Earth system scientists. A system is any entity that is studied as a whole and typically has exchanges of energy and materials with the surrounding environment. This means that there are lots of different things that can be viewed as a system. The Earth is a system, but so is a plant. A lake is a system, but so is a human body. Let's talk more about a plant as an example. A plant undergoes photosynthesis and respiration, and in doing so exchanges nutrients, water, energy, and gases with its surroundings. The Earth system is made up of many different interacting parts, but everything can be placed into one of the four major subsystems of the Earth system. The lithosphere, sometimes called the geosphere, is the land and includes all things related to geology. Now, the lithosphere is also the name of the solid outer part of the Earth, the part that we interact with. That is why the name lithosphere is a little confusing for the name of a sphere, and some people call it the geosphere. Now, the hydrosphere includes all water on Earth. The biosphere includes all living organisms. Again, this name can be a little confusing because sometimes biosphere is used as a term for ecology on a global scale, basically all the biomes on Earth. And then the atmosphere includes all gases and air. The variables within these spheres interact constantly to create the different ecosystems and environments on Earth. One more thing that we should get out of the way early is the difference between climate and weather. We are going to talk about climate a lot in this class. We won't talk much about weather other than the way that storm systems develop. Both climate and weather have to do with temperature and precipitation, but the timescales are quite different. I think we're all pretty familiar with weather. It affects how we dress and whether we have to wear sunscreen or bring an umbrella with us. It can change hour to hour or even minute to minute. Climate is basically weather averaged over a long period of time. It doesn't worry about the day-to-day variation as much as what the typical pattern for an area is. With climate, we can track changes over time. Earth's climate has been relatively stable over geologic timescales. This has been a key factor in Earth's habitability. Earth's spheres actually interact to create Earth's climate. The hydrosphere and the atmosphere are obvious players, but the lithosphere and biosphere are also important. We will cover how in various lectures. There are many feedbacks within and between spheres which can amplify or dampen changes to climate. Humans can also affect Earth's systems and its climate. The reason why we care about the Earth system and the environment is because Earth is a closed system. This concept is sometimes called Spaceship Earth. Earth is a closed system, so in essence it is a ship hurling through outer space. This is because materials do not enter or leave. Only energy can, not matter. Also, resources are limited. Damage that occurs stays in the system, and the Earth is our life support system. The reason why there is life on our planet, and not others, as far as we have yet discovered, is because our planet is in a sweet spot in its orbit around our sun. This is obviously a huge factor in Earth's habitability. This sweet spot is sometimes called the Goldilocks zone, because if we were any closer to the sun, then our planet would be too hot for life. And if we were any further away from the sun, then our planet would be too cold for life. Not many planets occur in habitable zones around their stars. To prove just how important and far-reaching the Earth system is, I wanted to show you a long-term risk outlook published by the World Economic Forum. Many of the global risks they identified were environmental, meaning they have to do with the Earth system. These included climate action failure, biodiversity loss, extreme weather, like storms, extreme heat, drought, or cold snaps, natural disasters, and human-made environmental disasters. But many other risks also have to do with the environment and global change. For example, water crises are expected to increase with climate change, and certain infectious diseases are as well. Infectious agents are part of the biosphere themselves, and some are expected to be a bigger issue in the future due to climate change, as vectors like ticks or mosquitoes expand their ranges. Additionally, the risks that are classified as environmental will impact more than just the environment. For example, climate action failure will have large societal, geopolitical, and economic ramifications as well. So now I would like to go through and give some examples of how the Earth is a closed system, meaning matter does not enter or leave it, and changes in one part of one sphere can have wide-reaching effects. Another way of saying that is that events in one part of the Earth system can have a rippling effect. One really good example of this is volcanic eruptions. Volcanoes always involve the lithosphere, as it is a geological process. But volcanic eruptions also impact the atmosphere by ejecting gases and particulates into the troposphere and stratosphere. Volcanic eruptions can also impact the hydrosphere. For example, they can cause tsunamis. Really large volcanic eruptions, or series of eruptions in sequence, can actually instigate global cooling because of all the aerosols they inject into the stratosphere. These aerosols reflect incoming solar radiation. The Little Ice Age was a period of regional cooling between the 14th and 19th centuries, particularly pronounced in the North Atlantic region. While the Little Ice Age was caused by the cooling effect of massive volcanic eruptions, it was sustained by changes in Arctic ice cover. The Earth got cooler and there was more ice. Ice has a high albedo, meaning that it reflects a lot of incoming solar radiation, so that solar radiation doesn't get a chance to warm the planet. This reinforces the initial cooling and is called a positive feedback. We will cover the ice albedo feedback much more in future lectures. Here is some artwork from the Little Ice Age. The Thames froze in London. You can also see the canals in Denmark froze, which isn't a super common occurrence. Forest fires are another good example of how the different spheres in Earth's system are connected and how changes in one area can have a rippling effect. Forest fires affect the biosphere. The biosphere serves as the fuel for the fire. But the atmosphere is also affected. Smoke is produced. Furthermore, the atmosphere affects which direction the smoke blows and how the fire spreads. The hydrosphere and the atmosphere also affect rainfall, and thus affect how easily the biosphere burns. Rainfall may also aid with putting out the fire. Of note is that extreme catastrophic fires are increasing due to global change. The last example I am going to give you that demonstrates the connectedness of the Earth systems has to do with hurricanes. Hurricanes are an interaction between the hydrosphere and the atmosphere. Sometimes all we can do is get out of the way because Earth system processes are so massive. You can see this particular hurricane, Hurricane Laura, from space. Of note is that hurricane wind intensities are increasing due to global change. This is due to warming ocean temperatures and more moisture in the air. Thanks for sitting through the lecture. To test your learning, I suggest you go through and answer these questions as you review the material.